Hello world, this is Craig. Say every once in a while I look at the sectional and I just pick one quadrant and I want to make sure that I understand where everything in that quadrant came from or what everything in that quadrant means. So one of the things I want to look at in this quadrant is the maximum elevation figure. This is a quad in Northern California, Northern California. And we can see the maximum elevation figure here is 8,600 feet. The question is, where did that come from? So by looking at this quadrant, first thing that we can do is look for the highest natural object on that terrain. And we see that down here. It's Boulder Peak, and the elevation of that is 8,299 feet. So where did that come from? Well, if we look at a topographical map from the USGS, and I have a copy of one here for this particular area. So here's Boulder Peak, and you can see that the elevation given for Boulder Peak is 8,299. Okay, well that makes sense. The question is, what is the accuracy of that elevation? Well, the USGS topo maps are absolutely amazing. How much information they have documented for the US, but there's bound to be errors. So if we look at the accuracy standards from the USGS, we see the following. For each 7.5 minute quadrant in the topo map, they will take about 20 points, and these need to be well-defined points that they know exactly where they are and they know the elevation. They will check those points, and 90% of those points tested have to be accurate within half a contour. So if we look at our map, and if our contours are 500-foot contours, then the accuracy has to be 250 feet. Or if the contours are 100 foot, the accuracy has to be 50 feet. So on this map, the contours are 200-foot intervals. So that means, according to the USGS, if a contour is correct within 100 feet, it's okay. So now let's go back and look at the sectional. So how did the FAA select the maximum elevation figure of 8,600 feet? Well, first of all, they have to determine, is the highest object in this quadrant natural, or is it man-made? And if it's man-made, is it more than 200 feet tall? So those are the two categories, either man-made and more than 200 feet tall, or a natural object. In this case, it's a natural object. So you start with the 8,299 feet, and you add to that the error. And the error is, according to the USGS, half of a contour. Contours are 200 feet, so you add to that the error of 100 feet. So that takes you to 8,399 feet. Now, since the highest elevation is from a natural object, let's say it's a tree, trees grow, so over some period of time, that natural object might get higher. So let's add to that 200 feet for the possibility that whatever's up there is going to get taller until the next time that this particular spot is remapped. So we go from the 8,299 feet, which is its actual elevation, to 8,399 feet if we include the error. So then we add the 200 feet for future growth of the tree, and that takes us to 8,599 feet. And then we just take this up to the next 100-foot level, because when we report the maximum elevation figure, we only show the thousands and hundreds. So that takes us to 8,600 feet. Okay, so in this case, the contour interval was 200 feet, and so the error was 1/2 of the contour interval, which is 100 feet. But what's the general case? Well, if we look at the Aeronautical Chart User's Guide, add the possible vertical error of the source material 100 feet or 1/2 the contour interval when the interval on source exceeds 200 feet. So in other words, even if the USGS map has a contour interval of 10 feet, the error that is used in the calculation is still 100 feet. However, if the contour interval is 500 feet, then the error would be 250 feet. So basically, the error is always the greater of 100 feet or 1/2 of the contour interval. So I've heard many people say when they look at the maximum elevation figure, they say, well, that gives me 300 feet clearance above any object in that quadrant. And that's not actually true. In this category, which is either natural object or man-made objects less than 200 feet. So if someone came and added a man-made object of 200 feet on top of Boulder Peak, that value would not change. 8,299 feet to the top of Boulder Peak, half a contour interval, which is 100 feet, and then someone has come and put a 200-foot tower on top of that. And so now the top of that tower is at 8,599 feet. That is then taken up to the next 100-foot interval, which is 8,600 feet. So if we fly over the top of that tower at 8,600 feet, we'll clear that tower by a foot. Not the 300 feet that I hear lots of people claim is built into that maximum elevation figure. So what if the object is man-made and not natural? Well, if it's man-made and more than 200 feet, the calculation is elevation of the terrain plus the object plus the possible error, but we don't add the extra 200 feet for future growth, because if it's man-made, it's probably not going to get much taller. So in this case, we can see a tower that is 420 feet tall above the ground. So the top of the tower is 1,482 feet MSL. For this quadrant, the contour intervals are at 10 foot, so we take the minimum of 100 feet for the error. So we go from 1482 to 1582 for the error, and up to 1,600 feet for the maximum elevation figure. Now here's an interesting one. Here we see that the highest natural feature in this quadrant is 2,430 feet. And the highest man-made object is 2,536 feet. So in this case, the man-made object is 100 feet higher than the highest natural object. But which one was used for the maximum elevation figure? Well, the 2,430 foot natural elevation, we put in the 100 feet for the contour error, and then 200 feet for future growth. That gives us 2,730 feet. If we take that up to the next 100-foot interval, it gives us 2,800 feet. Now if we look at the man-made object, it starts at 2,536 feet. We add in the same 100-foot possible error for the contour. That takes it 2,636 feet. Take it up to the next whole 100. That's 2,700 feet. So here's a quadrant where the highest object in that quadrant is the tower, but it is not what was used for the maximum elevation figure. Okay, well that's just my opinion on this. I'm not a CFI or anything, so think for yourself, use your common sense. But I hope this has been useful. Thanks.